First of all, thanks for joining this talk, and thanks for being here in Barcelona. It's a pleasure to be here and talk about WebAssembly and especially Spin. So let me quickly introduce myself. My name is Thorsten. I work at Thinktecture, so we are a consultancy in Germany, and our core mission is to help other developers adopting technologies and mastering the challenges on their journey while adopting new technologies. We strongly believe that WebAssembly will change the way how we build software, not just in the front end, because we have that innovation already there, happening for quite some time, also on the server and in the cloud. So that's why I'm here, basically. And the most important thing on that slide is my mail address. So if you have any questions afterwards, don't hesitate, just shoot me a mail or grab me over here. We're here until tomorrow afternoon, I guess. So yeah, feel free to reach out. So let's have a look at the agenda. First, I will ensure that everybody's on track so that everybody has a common understanding of what Spin actually does and what we can get from actually using it. Before we take a look at some key components that Spin provides us in order to build applications. And then we will cycle through some patterns and practices that I found really valuable when building distributed architectures, so to say, where we leverage both containers and WebAssembly, because that's, from our point of view, how the short and mid-term future will look like for average, application developers, so to say. Last but not least, we will wrap this talk up and have some key takeaways in the slides that you could browse through after the conference too. All right, so without further ado, let's jump right into what Fermyon Spin actually is. So basically, it gives you, or it contributes 3 pillars to the overall story, right? It is a serverless runtime built on Wasm time, heavily leveraging WebAssembly component model that allows us to run or to get our reactive applications executed in a serverless fashion. So that's the first pillar, it's a runtime. Second, it's a bunch of SDKs available for different popular programming languages. And as you already see, there's Ferris in this slide deck. That means all the samples I have in this talk will be in Rust. However, you can use and build Spin applications with every language that compiles down to WebAssembly. Right? They have WebAssembly gateway interface executor baked in the runtime, so you can just throw your WebAssembly module over there and instruct the runtime to get that executed. So second is the SDK, or the SDKs. Third is super focused developer tooling. Because, that has been the rocky road for application developers when it comes to WebAssembly. It's the dev story, right? It's how to stay or remain productive in doing our day-to-day job. So with Spin, we got the Spin CLI that has just a few, let's say, sub-commands that we can use to create new applications, to compile our code to WebAssembly, to run the applications, or to deploy them. So those are the 3 pillars: runtime, SDK, and dev tooling that Spin contributes or provides us as developers to enter the world of WebAssembly when it comes to serverless or reactive applications. And Spin does so by, paying respect to all the key values or attributes that we assign with WebAssembly. So obviously, our serverless applications are fast, right? I mean, who has done some serverless? Maybe showing some hands? OK, a bunch of you. Who has not, or who was not involved in discussions about cold start times? One. You weren't involved. Okay, interesting. I did a Google, did a search yesterday, and there were more than 15 million results when you ask for cold start times in serverless, you know, replacing serverless with Azure Functions, AWS Lambda, and so on and so forth. So that's always a topic, right? Our applications will obviously be lightweight, speaking about size of the distributable. I mean, if you compare a WebAssembly module to a container, we're way smaller, right? And let's just skip virtual machines, because virtual machines and serverless, well, doesn't work at all, right? Last but not least, obviously, we have a secure environment, right? We have WASI, we have WebAssembly in general as a basement that we can build on. So we have a secure environment that's important for us as application developers to, you know, have the trust that everything works as expected and we don't introduce some, you know, vulnerabilities or so. And obviously also for the vendor side, right? That they can accept WebAssembly modules and don't have the fear that something goes terribly wrong. Okay, so I said a short introduction, and let's quickly jump right into the terminal. Oops, so that messed up my resolution a bit. So I have Spin installed. So I can say, hey, Spin, please create me a new application in the current folder, and I can choose from different templates. So I haven't installed all the templates that are available. That's just a subset. But for now, let's say I want to create a new HTTP-based application using Rust, and let's call that Hello Wasm IO. And let's stick with the defaults and fire up code in the current folder to see what we actually got here. So we got a manifest, right? The Spin TOML, that's the center of gravity for all Spin applications that you are going to write. We will come back to Spin TOML in other demos. And we got our application code. And this is just some regular Rust code, right? Decorated with the HTTP component macro that, you know, will instruct the runtime to invoke this particular function if something, an HTTP request, happens. So let's replace Fermyon with Wasm IO over here, and let's move back to the terminal. So let's clean this thing up. So we can do a Spin build, and now we heavily depend on the internet, and the internet is fast. That's good. So it compiles my Rust code for the WASI platform right now. That's finished. And again, I can use a Spin up and start my application. The listen argument is totally optional, but I'm running some other applications in the back. So we are now running our application on port 3001. We can come up with the best UI ever, that's curl, right? And get our application invoked. So Spin makes it super easy to get started, you know, to have a foundation that we as application developers can use to build apps. However, this is Hello World, right? Or to be more precise, it's Hello Wasm IO. Let's have a look at something different. So I have created a demo application, and I'm a developer, I'm not a designer. That being said, so it looks nice, let's say it. This application allows me as a speaker to keep track of all the conference talks I do. So I have a list of conference talks. I can add a new one, spin it, we are at Wasm IO. I can submit a new session. Behind the scenes, hopefully, depending on the internet, actually it should have already happened. Let me quickly check. Let's go there. Oh no, it's saying, there we go, 12:14, that's now. Somehow the notification didn't find its way through the DND. So I got a mail saying, hey, there has been a QR code generated, right, for that particular talk. I also got, and I don't know why, this has not been a batch, I got a Slack message over here saying, hey, there has been a QR code generated. So I can open up this link that points me to the QR code that I can share with my audience. Taking pictures of that QR code actually doesn't work because it points to localhost for the demo, so bear with me. However, I have a simulate scan over here, right? So this allows me to provide feedback about my session. So the topic is obviously high in relevance. Well, knowledge of the speaker, yeah, I don't want to give me 5 out of 5. So let's say the speaker walked around too much, and slides did not contain any kittens. So that's the feedback, right? I can submit the feedback, and that's the attendee view or the attendee part of the application. Me, as the speaker, I can come back to the list and can have a look at the results and obviously get the feedback. I mean, that's fairly simple right now, and again, it's super nice design, right? And if I have multiple votes, I get averages and can see how how my speaking habits or how the presentation quality evolves over time. So to say, simple application, and let's go back to PowerPoint to actually, oops, is that the right one? Yeah. To have a look at the overall architecture. So as I said, we think that in a mid or short-term future, the conjunction of containers and WebAssembly is what we will see. So we have two, containerized, let's say, components that have been there, like a front end, like the heavy lifting, right, the QR code generator. So there was no need to change that. However, we have other parts of the application, like the HTTP APIs, that, that look as a quite good fit for adopting WebAssembly, and especially Spin over here. And the same down below with the notification sender. So we have the Sessions API and the Votes API, dedicated WebAssembly modules. The one takes care about the sessions, stores them in a dedicated storage. Votes, again, exposes the Votes APIs and also stores them in a dedicated database. And if a speaker creates a talk, then a message is been sent to a queue. The queue, the container listens to that queue, does his work, creates a QR code, and emits another message to another queue. There we have another Spin application listening for messages in that queue, and then, sending the notifications. In my example, it's using a Slack app, how that's called in the meantime. Previously, it was called the incoming webhook. And we use SendGrid to send out the mails. All right, so we will come back to that sample over and over again during the talk. So I thought it would be worth, giving you some insights about what's behind the scenes and what's WebAssembly and what's, running plain old containers. All right, so Spin gives us two fundamental things. First, we have so-called triggers. So triggers are, ways how we can instruct the runtime. We can say to runtime, hey, if XYZ happens, please instantiate my WebAssembly module and call into my custom code. So currently, Spin offers two different triggers. So we have HTTP triggers. We saw that already, right? And we have this subscribe part of PubSub. So we can get our code invoked if a message appears in a queue. So those are the triggers that Spin currently provides that we can use to build reactive applications. The second idiom, let's say it that way. So if you're building applications, you somehow deal with data, right? And you somehow have to interact with external systems. So with Spin, we can currently, talk to databases, right? So I've listed all the systems that are currently supported over there on the slide. So we have a possibility, to build CRUD APIs. We can talk to key value servers or systems like SQLite or like Redis. For PubSub, we can use Redis channels as of today, and we can send outbound HTTP requests. And taking those triggers and those outputs into context, we can already build fairly complex distributed architectures. Maybe you're the lucky one who is able to start from scratch, greenfield. But also in brownfield applications or environments, you can quickly identify places. For example, I often refer to those components as satellites, where you can, bring in some WebAssembly, so to say, and triggers and outputs, help us in actually doing that. Okay, so with that, I want to share some of the patterns and practices I found valuable when building or when adopting Spin almost a year ago, not exactly a year ago, and throughout that journey, right? So first, we saw Hello Wasm I, right? Fairly impressive, yet fairly simple. So we have those triggers and instruct the runtime, hey, on a certain path or underneath a certain path, please invoke my WebAssembly module. However, it is our responsibility as an application developer to take care about routing and to implement handlers for all the things HTTP. So I have that front-end application that's running on a different origin. So I have to take care about CORS, about cross-resource origin sharing, right? So those are things that are in my responsibility as an application developer. However, although the SDK is tiny and focused, it makes building that logic super easy. So let's have a look at that. And for that, not Outlook. We want to demo over here, the purple Visual Studio. So first of all, let's have a look at the Spin manifest. As I said, that's the center of gravity. Everything is wired up over here. So as you can see in line 5, I have a trigger of type HTTP, right? So I can register multiple components in a single Spin application to get and have them invoked based on a path. So for example, the sessions component is invoked for requests hitting /sessions and everything underneath. The second component, because it's also an HTTP application, is the votes API. Okay? The votes, so my component is triggered for requests hitting /votes and everything underneath that. So this is fairly easy, to mix and match your WebAssembly modules and, orchestrate a bigger system. However, if we have a look at the sessions implementation itself, so we have the handle sessions function, the one decorated with HTTP component over there. And then I just simply use enums in Rust because they are so powerful compared to enums in other languages, in combination with pattern matching. So if we take a look at the implementation of the from trait, I simply, take a look at the underlying request, and the request is provided by the SDK. So I can say, okay, is it a post request? Is it the get request? Is it the options request? Whatever, right? So for example, for get requests, I also take a look at, hey, is there an ID in the route, and am I able to convert it to an I32? And if so, then I treat this request as a request that has the intent to retrieve a session by its identifier. Okay, going back into the handler or the handle session method, we can look for the read by ID variation And there I just invoke the handle read by ID. Let's jump into that one. And you see I leverage the Spin SDK for MySQL to retrieve the session from the data storage and construct a response, send a response back. So, building apps that go beyond Hello World obviously requires us as application developers to currently come up with some sort of routing capabilities, but different languages have different answers to get that up and running quickly and in a robust way. Okay, next is outbound HTTP. Outbound HTTP is super useful when modernizing applications, right? So you can call down to your backend APIs that perhaps you may not want to expose them to your API consumers or third parties, or you may want to call into third-party APIs. So outbound HTTP capability is super useful, yet super simple. And for that, let's go back to the purple Visual Studio. Let's go to the notifications app. Again, this is a Spin application that's responsible for sending emails using SendGrid and messages using Slack. So we go to the implementation of Slack, and we see we use the Spin HTTP functionality to construct our outbound HTTP request and, ultimately to send it. However, we run in a secured environment, right? So we have to configure or to express our intent to actually send outgoing HTTP requests. And we have to do so in Spin TOML by specifying allowed HTTP hosts, as you can see over here in line 17. So without adding this, my WebAssembly module would not be able to call either api.sendgrid.com or hooks.slack.com. Okay, so super simple, yet super useful while adopting WebAssembly on the server using Spin. All right, next one is configuration management. Configurability is key when it comes to building distributed applications that run in different environments. And Spin is no exception here. So luckily, we have a story to deal with both sensitive and non-sensitive configuration data, right? So again, Spin TOML, that's where everything is wired up. So we can bring in non-sensitive configuration data by specifying variables. We can override them at runtime using environment variables, batteries included, so to say. So for sensitive configuration data, we can instruct Spin applications to consume sensitive data from HashiCorp Vault. And I bet we will see additional secure store systems in the future. But for now, HashiCorp Vault is the way to go. And we link an existing vault to our Spin application by providing a runtime configuration. And for demonstration purpose, yes, my token is in that file in plain text. But bear with me, that's just for demo, for the sake of demonstration, to explain the concept over here. So if we take a look at the Spin TOML again, we see I have some variables. Those with default values are treated as non-sensitive configuration data. The others that I make available to every component using the component config block are sensitive configuration data. Once I've that in place, I just need to use the Spin SDK, right, to load the config at runtime. And that's it. And then I have configuration data in my WebAssembly module and can work with it. I can use it, right? All right. Last but not least is publish, subscribe. So I found that one super useful to actually bring in some WebAssembly into existing applications because, okay, it's configuration. I have to tell the runtime, hey, there is the Redis channel that I want to listen to, right? But then again, it's my burden. I have to construct what kind of message I want to deal with or how the message should be materialized. And this gives me the way to plug in Spin applications in systems that maybe use cloud events or that use some custom message schema. So no matter if you use a channel to, for a single type of message or for different messages, you can deal with that. And let me quickly show how to do that. So let's go to the notifications handler. Notifications, and over there, let's get rid of that one. So I came up with a notification model, and I said, OK, this is how a notification message that I want my application in Spin to react on, how it should look like, right? So I designed that struct. I configured 30 to have everything with proper casing in place. And then I grab every message from that channel. But if the message doesn't fit my schema, my struct, I just stop the execution because I'm not interested in that particular message. However, this implementation is able to deal with all the notification messages that match my schema. So this makes it super easy to bring in Spin into existing distributed applications. OK, that being said, and paying respect to the watch, let's come to the conclusion, right? So with Spin, Fermyon demonstrates how WebAssembly will change the way we build software for the next wave of cloud computing. WebAssembly will dramatically change the way how application developers build distributed applications that run in the cloud, no matter if the cloud is public or private. Right? We can, as of today, mix and match best from both worlds, from containers and from WebAssembly. And that's great. Although we have SDKs for many popular languages, as soon as the language you want to use compiles down to WebAssembly, you can use it. You can use it and build your applications with the language you love and you use every day. So for me, there are some or several opinions when it comes to WebAssembly, right? So on the one side, we have the hyperscalers, the cloud vendors, right? So they want to drive hardware utilization way up. They want higher density, more and more applications on the same amount of compute power, and obviously proper isolation. They won't finally be able to scale down to 0 and scale up in no time. And yes, sorry, Azure Functions didn't work out the past years. Sorry. So they have a huge interest in adopting WebAssembly because that saves a whole lot of money. And there's the gap, right? The story for the average application developer wasn't that good up until now. So there were lacks of SDKs. There was, developer tooling was there, but it wasn't that good, right? Debugging is still a way where all the entire ecosystem could and should improve. However, from my point of view, Spin is able to close that gap, and to bring those two positions closer together in order to, help everybody or help us, bringing WebAssembly adoption to a whole new level. And with that, I want to say thank you for your attention. And because we also already run a little bit late, I would kindly ask you if we could take the questions offline to come back to the regular conference schedule. Or maybe can we take 2 questions? Yeah, cool. OK, 2 short questions. Questions over there.
Great talk. I'm curious. I really want to try out Spin, but I have this large monorepo with several cargo workspaces existing. And does this tool really fit into not being the centerpiece in my toolchain, but being incrementally adopted? Because I cannot jump in with both feet. I have to just try it out first.
Well, so you know what I typically see when it comes to the adoption is it's a super fit to identify how I refer to them as satellites, right? Like tiny little pieces that you could simply extract from your overall bigger system and distribute them, you know, across different, let's say, servers traditionally or containers or whatever. Implementation-wise, I mean, the sample I have, and I will share it with in the conference app and via Twitter, that's also using cargo workspaces in order to get everything in place, in order to share some, you know, code between different Spin applications. So I would, my assumption is, I mean, you know, you have to take a look at the overall architecture and identify pieces and bits or areas where you could easily step out and say, okay, and here we use, for example, a queuing pattern like pops up in order to, you know, bring in Spin at that point in time. Okay, there's another question over there. Oh, we have to? Okay. Okay, anyways, so I'm around until tomorrow afternoon. Just come by and ask. And thanks again for your attention.